Welcome to this video on graphing equations. This one covers the subject of equations of circles. Okay, let's try graphing this equation using our t-chart method. What we have to do first is we have to solve the equation for y if we want to do this, okay? So let's try that. We have x squared plus y squared equals 1. So maybe I subtract an x squared from both sides and I get y squared equals 9 minus x squared. And then to undo the square on both sides I do a square root, but because I do that I have to add a plus or minus, right? So what I end up with is this equation, y equals plus or minus the square root of 9 minus x squared. That's the equation solved for y, okay? And that makes it so that I can plug various values in for x and see what comes out for y. So let's try this. Let's try negative 4 in for x and see what we get for y. This is going to be plus or minus square root of 9 minus negative 4 squared. But that is, what is that? That's plus or minus the square root of 9 minus 16, right? Which is going to be a negative number. 9 minus 16 is what, 7? So that's a square root of negative 7. And we can't take a square root of a negative. So that means that there is no point when x is negative 4, right? In fact, it's not until I get to negative 3 that I start getting values here for y. Plus or minus the square root of 9 minus negative 3 squared. Well, negative 3 squared is 9, so that's the square root of 0, and so that's just 0. So when I plug negative 3 in, I get a 0 out for y. So there's one point that I can put down. When x is negative 3, y is 0. All right. Okay, let's try putting in negative 2, right? So I would have plus or minus the square root of 9 minus negative 2 squared, right, which is going to be 9 minus 4, which is 5. So that's plus or minus the square root of 5. And what is the square root of 5? The square root of 5, well, the square root of 4 is 2, so it's something a little bit more than 2. When I plug a negative 2 in, I could either have a positive square root of 5, or I could have a negative square root of 5. So actually there are two different y values that go with that x value, right? If I plug in a negative 2, I get negative 2 positive square root of 5, which is a little more than 2, or negative 2 negative square root of 5, something like that. So I have two different points there. All right. Let's jump down here to 0. Actually, let's do 1. So if I do negative 1, let's see, 9 minus negative 1 squared, that's going to be plus or minus the square root of 8. And the square root of 9 is 3, so it's something a little less than that. So if I plug negative 1 in, I get positive the square root of 8, or I could also have another point. I could have negative square root of 8 out for y. So if I plug a negative 1 in, I could have something just a little less than 3. Or the negative of that, right? And if I were to plug 0 in, I would have plus or minus the square root of 9 minus 0, which is just plus or minus 3. So I have 0, 3, or 0, negative 3, right? So 2 points for x is 0. 0 is 3, and 0 is negative 3. Okay. If I were to plug any of the positive values in, I actually get the same numbers as I would have with the negative values. The reason why is because when I plug something in here, it just gets squared. So it doesn't matter if that was negative or positive, I'd have the same result. So the result is when I plug a positive 1 in for x, I get positive square root of 8 and negative square root of 8. If I plug a 2 in, I get the square root of 5 and the negative square root of 5, right? And if I plug a 3 in, I get 0 again. And so what I've done is, if I draw a curve through all those points, you can see the shape. This is the equation of a circle. Okay, so x squared plus y squared equals 9 is the equation of a circle. Okay, so a couple things to notice. First of all, the center of this circle is at 0, 0, right? And the radius of this circle, is 3. Okay, one thing I notice is that this 3 right here, if I square that number, I get this number, the 9, right? So we're going to take advantage of that in a little other section. So this is actually the basic shape of an equation of a circle. It's got an x squared term plus a y squared term equals a number term, right? And the number term is the radius squared, okay? Now this is a pretty cumbersome way to graph a circle, to try to solve it in this form and then to plug x values in and y values, things like that. It's even worse if it's not just x squared plus y squared. Let me give you another example, okay? What if I made the equation this, x minus 2 squared plus y minus 3 squared equals 9? This is quite difficult to solve for y, but if you do, you get this. Y is 3 plus or minus the square root of 4x minus x squared plus 5. Okay? And if you try to graph this using the same methods, let me just actually show you what happens if I plug this in. It's a lot of work to do this, but just to kind of show you the result. If I plug a negative 2 into that, I actually get something that includes the square root of a negative, so there's no point at all there, right? It's undefined. But if I plug a negative 1 in, I get 3 out. So one of the points is negative 1 comma 3. So let me put this on the graph, negative 1 comma 3. Okay? If I plug a 0 in, I end up getting 3 plus the square root of 5 and 3 minus the square root of 5 out. So the points are 0 gives me 0.76 out or 5.24 out. Those are the two values, plus 3 plus square root of 5 and 3 minus square root of 5. So let me add those on the list here. When x is 0, y is 0.76, about there, or 5.24. 1, 2, 3, 4, 5.24, something like that. Okay? If I were to plug 1 in for x, I end up getting 3 plus square root of 8 out or 3 minus square root of 8 out. And so I have 1.17 or 5.83, right? So 0.17 and 5.83, almost 6, okay? And if you plug 2 in, then you get 0 out, which is 3 plus or 3 minus 3, or you get 6 out, 3 plus 3. So 2, 6, or 2, 0. And then there's a corresponding case over here if you take the negatives. So in reality, this is the curve. It's still a circle, but something's happened to the circle. Well, the center is moved. That's the first thing that I notice. Where is the center? Well, the center of this circle is 2 over and 3 up. So 2 comma 3. And if you notice, that matches the numbers that are in the original equation, right? This equation was modified. Instead of x squared plus y squared, it's x minus 2 squared plus y minus 3 squared. And if you carefully, laboriously plot this thing out using t-chart, you'll find that the center has moved so that the x-coordinate of the center, this 2 right here, is the negative of this number. If this is a minus 2, that center x is positive 2. Same thing for the y. If this center is positive 3, because this number right here in the y term is negative 3, y minus 3. Okay, so we don't have to graph things this way. We're going to find a much easier way. We're just going to take advantage of what we've learned here from graphing these by hand. What we've learned is that the general equation of a circle is this. It's x minus h quantity squared plus y minus k quantity squared equals r squared, where h, k, and r are numbers. So the first thing is the number that's by itself on the right side, that's always the radius squared. And the numbers that are inside the terms, those are the negatives of the x and y coordinates of the center. Okay, so let's just give an example. If I wanted to graph this equation, how could I do that? Well, I could just draw an axis here, x, y, and I would just do this. I would say, okay, where is the center? Well, the center is going to have an x and a y, okay? The x right here is going to come from the x term. And since this number is a negative 2, I'm just going to take that number and take the negative of that to make it positive 2. The reason for that is that this number 2 is actually the h, and since there's a minus in the standard form equation, we have to take the negative of that number, or you can consider the h as just the 2. Same thing here. This is a negative 3, and so the y coordinate of the center is positive 3. So I would just go over 2 units, up 3 units, and draw a dot there for the center of the circle at 2 comma 3. Then you can take the number that's out here and know that that number is equal to r squared and figure out what r is. Well, in this case, the radius would equal 3, because 3 squared is 9. And so then I can go 3 in each direction. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Just go 3 in each direction here, and then draw 4 points and sketch out a circle. Okay, so much faster way to sketch than trying to do this with a t-chart. Okay, let's practice this. Just some examples here. If you feel like you have this idea, pause the video, give this a try, and then come back and see if you got it correct. All right, as I look at this, let's find the center. Well, the center has an x and a y coordinate. The x is this negative 1 but made positive. The y is this negative 5 but made positive. So the center would be at 1, 5. 1, 2, 3, 4, 5. There's the center. Okay, now the radius, this number out here is radius squared. So the radius would have to be 2, because 2 is the square root of 4. And so I can just go 2 in each direction here and draw a little dot. 2 in every direction. That was too far. All right, and then I can just draw a smooth circle through those curves because I know that this form of equation looks like a circle. Okay, a couple of other examples. So it's very hard to do this if you have to solve and do T-chart method, but actually doing it from the standard equation is much, much faster. What is the center of this? What's the radius in graph? Okay, the center here, well, we would get the x from the x portion, but we'd take that positive 3 and make it negative. We would take the negative 5 and make that positive, and the radius would be 4 because 4 squared is this number 16. And so where is the center here? At negative 3, positive 5. There's the center. And then I have to draw a radius of 4, so I go 4 in every direction from that center and put little points that are on the circle, and then I just draw sketch a circle through those points, something like that. Okay, what about this case? Where is the center of this one? Well, the center has to have an x and a y component. The y definitely is positive 2 because I take that negative 2 and change it to a positive. But what about here? There's no number here at all. Well, since there's no number, if you recall, when it was just x squared plus y squared, the first one that we graphed was x squared plus y squared, that was centered at the origin, right? So actually that means that the x coordinate here is just 0, right? Another way to think of it is x squared is the same as x minus nothing squared. So you can just say that since there's no number there, there's a 0 for the x coordinate. So the center of this circle is 0 in the x direction, 2 in the y direction. And then this number here is r squared, so the radius would have to be 6. So I could go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then try to sketch a smooth circle through those points. Okay? All right, let's take a couple more examples. What about x squared plus y squared? Where is the center of this circle? Well, since there's no numbers at all, they're just 0. This circle is centered at 0, 0, at the origin. And what about the radius? Well, I know that this number out here is r squared. Now, there's no integer squared that would be 20, right? So I'm going to have to just actually solve this little equation and say r is the square root of 20. So that's a number, even though it isn't an integer, right? So about how big is it? Well, let's see. The square root of 16 is 4, right? The square root of 25 is 5, right? So we know the square root of 20 is somewhere in between there, right? Somewhere in between 4 and 5. Okay, so for sketching purposes, I'm just going to estimate that it's about 4.5. And so I'm going to go 1, 2, 3, 4, and a little bit more. 1, 2, 3, 4, and a little bit more. 1, 2, 3, 4, and a little bit more. 1, 2, 3, 4, and sketch that way. If I wanted to, I could indicate that that radius is the square root of 20, like that. Okay? All right, so that's how we deal with equations. We don't, equations of circles, we don't graph those with T-charts. We use the standard form. Use the standard form to quickly find the center and the radius. Don't forget that you need to change the sign of the numbers to get the h and k. So if it's x minus 2, then that means that the x coordinate of the center is positive 2. Make sure that the x coordinate comes from the x term and the y coordinate comes from the y term. And then the radius is just the number squared that equals the number on the outside. It's not that number squared. So if you had something like x squared plus y squared equals 9, you should know the radius is 3, not 81. Some people will think that the radius is 81, but it's the number squared that's equal to that number. Okay? All right.